Hello everybody. I'm an FL developer, FL the language since 98 and C developer since 87, C++ developer since 91, and now for my home works I only use FL language. That's all. So I'm currently designing a compiler, and I was needing an operating system. I'm also interested in microkernels. The first thing that I want to do was to rewrite L4 kernel, microkernel, using FL. But it would be very useful. First, I read some security books on the topic of microkernel, and so what is interesting is that managing security by the language is an interesting challenge. Second, I had difficulties to find security implementation that was not using memory management units or flat memory. I've seen some C library that was implementing interesting things about that to implement only flat memory, but maybe the most issue is that the scoop model doesn't really fit with this kind of microkernel that are L4 or other microkernels. Why? Because it uses memory, it uses the principle of processes. Each process has its stack, and because there is a context switch when you are making IPC for so now scoop simple concurrent object oriented programming. Open your minds, because if you don't know what it is, I will present it to you, and maybe you can be interested. First, a few of terminology. That's not mine, I'm sorry, but that's the one of Bertrand Meyer, that is the thinker of this way of programming concurrency. So a processor is a set of objects that shares the same memory. Then inside a processor that is viewed as one thread, anything is accessible in the normal way. Okay, no concurrency. Only one thread, same set of objects managed. Oh, in FL, memory is managed. Okay? Objects of a processor can invoke objects of another processor, but it's a particular thing. These remote objects are called separate, and separate is a keyword in the language that is used to track fact that objects that are referenced are from another processor. So it appears in language when you read the code that object is not managed here, but somewhere else. No. We will not go more in detail. Now, just simple FL language. Who speaks FL here? Okay. So deferred means it's not implemented here. Okay? Just abstract. It's a class. The class is a template class. X here is something, an object, another class. So that's a FIFO, first in, first out. So we have very few features. That's the name, features. Is the FIFO empty? Is the FIFO full? Put an item in the FIFO. What's the first item in the FIFO? And drop the first item. In FL, that was a language that at first had the concept of contracts. You can see here some contracts. To put an object, it requires that the FIFO is not full. To get an item, it requires that the FIFO is not empty. And that's the same for dropping. So, but when you drop an object, so you ensure that the FIFO is not full. Maybe we can avoid it. Not that, but this one is maybe not useful, but it's interesting. So at least in invariant, your FIFO has at least one element. It cannot be either empty and full. Okay? Very simple questions. Let's go. Then we now use the separate keyword, because here we are writing some client. The client will order some task. That's something here very abstract. And it will push the task to the FIFO. So it requires that the FIFO is not full. And then it puts it. Well, during execution, here are some remarks to do. First, you cannot invoke a separate object if the separate object is not an argument of the feature. That's important. Second, the contract here acts as a barrier. You cannot access QObject, this separate object, if it's already running, already used, already lent by some other process, some other object. Then it acts like a barrier. Then first lock access to Q. Then is it full? Yes. Wait, release the queue, and when the queue changes state, try another time. That's in the language. Then you have it, put it over. For the server, that's the same thing. He used the task, the FIFO, and then it requires that the FIFO is not empty. Get the item as a result and drop. And an interesting point is that here is a query, you have a result. So here is a synchronization. The synchronization is on need. Then here you wait for the result. Here you don't wait for the action to be finished, and here you don't wait also. So, questions? Let's go. Well, I summarized this design here. You have at the left 3 clients. You have in the center the FIFO, and at the right the server. Links here are showing that this one reference this one reference this one, etc. As you see, FIFO is not referencing anything except tasks that are put in, but it's not shown. Well, doing that with POSIX system, that old POSIX system, is just using maybe an Unix domain socket that will serialize the request to the task. So you have to make a serialization. And when you make the serialization, take care that no one else is writing in the same socket. Okay, but it may work. And here you have to deserialize, but you will see that the server and the FIFO using Unix domain socket are seen as if the FIFO is in the server, but it's in the kernel, okay? Well, no. For efficiency, having such a small object as separate, having its own execution context, that means having its stack, is not very powerful. So it's not wanted. There is a fact is that Scoop tends to have such kind of object without stack, with only data. And even if you want to have a system that implements persistency of objects in databases, but objects that will be active objects, not just data, then this kind of object will be Hudge. Okay? So, FL kernel, the principle is that processor are not processor, nor threads. They will get their execution context on need and release the execution context at the end. Well, when invoking a separate object, then the language semantic is used. So the context is either length to the called process. That's the case when result is expected, but we can imagine also, because I will speak about it later, that optimization can also lend the context for small function invocation. And a new execution context is created on need in case of command. Okay. Well, let's see it on some graphical view. So here are instances of classes. So it's called objects, separate. You remember a separate that are processor in fact. Okay, I have the good word. Processors. Processors are set of objects in separate context. Okay, they have their own management unit, memory manager, and then we can see here invocation of several objects. This one is waiting for this processor because this processor is currently on this execution path context. Then here, an object in that processor has called an object in that processor that called an object, etc., etc. And this one wants to call some object here, but can't. You have to wait that this one will get will release it down. These are pure execution context that only in a processor, okay. Maybe they don't use foreign call. Well, oh yes, it may fail. Here, an object here wants to use an object in that processor. Well, that's not a valid design. So it will get an exception. Why? That's it. Okay? That's the language that wants it. Well, there is something that is not really studied, but maybe in high degree courses, often you are aware about it, but you cannot, you encounter the problem and then you are feeling that it's a real difficult problem. That is acquiring multiple resources. So here it's obviously done in the language. Then here I just for the illustration wrote that feature that exchange the value, that is the items, of two separate objects, and it's as simple as it, because the compiler, the system, ensures that A and B will be locked for the feature. Then no problem, that's done at the kernel level. You don't have to sort your mutex, assign it a number, and cross the fingers. Okay? Well, about safety. The language is safe. No pickpock, array boundaries are checked. Calling void reference is impossible. Wrong casting, there is no wrong casting at all. Memory is managed. Well, Scoop is safe because you cannot access the memory of a separate processor. You can invoke it, but that's all. And the last is my preferred thing. Oh gosh, who wants more right IPC, IDE, etc.? Well, using only one language is much better. You know, FL currently, there is what? Tobias reference is counting how popular our language. Don't try to search FL, okay? But when FL was running the shootout benchmarks of Aliot, it was in the top 5. That's compiled, and that's safe. Well, okay. So I said I will write the kernel using FL, but how is it possible? There is no poke, no peek, no casting. Well, in fact, this feature is available, but only for the kernel. You know, when you declare a feature, okay, here are some features that are declared. When you declare a feature, you can export it to precise clients. Okay. Then the compiler now will enforce the safety of this kind of feature, dangerous feature, that it is also providing by using that and by enforcing it into some mechanism that is still to finalize. But the principle is here. So, for example, there are in FL we speak of clusters of objects, of classes. Then clusters can layer themselves, and then if you have a cluster, we say, okay, that function will only be accessible to that cluster, and that's all. Okay? No one can do it. That's obscure, but the idea is something like that, kind of simplified view. Okay, the compiler library will provide unsafe things or dangerous things that could be useful, and very safe things. Then at least maybe FL, the kernel will use any of this, the system may or may not use any of this, and the application library will only use this one. That's an ID, okay. Memory. The context switch between disparate objects, because the language is sure, is not involving any memory management unit. So you, in the ID, okay. So the context switch is very fast. It's very fast, so as fast as possible. It can be just a jump, try to lock the other processor, get it, land it, and then call. Each processor, so as its memory manager, and I'm thinking that there will be an inheritance relation between the two. And there is a way of knowing what is the memory manager of any position in memory. So you can find the processor. That's very cool. But using memory management unit may be useful also. Well, for the stack, that's not really needed. It's just a facility. But there are other interesting features that are file mapping, large dynamic array, and isolating foreign libraries. FL is a language that allows you to call C function, Java function, etc. Well, maybe useful. But the MMU is global, not per processor. The context switch, I said few about it. So I will skip. Okay. Processors are created using the language, so it's the create keyword that's like new, okay? And when a processor dies, well, it's not in an execution context. There is no execution context to it, and it has no client. No one is referencing it. So process are managed like memory is managed. Process or garbage collected. That's interesting. Well, how does it work? Well, here the FIFO has 4 clients. Okay, it's alive. Well, here the FIFO has 1 client. And this client has an execution context. Well, so the server is waiting for something to do. Well, but it may wait a long time because no one else is updating the state of the FIFO. So it will get an exception. Optimization. The previous talk was about Toro, and Toro was envisioning to compile an application and you get the kernel with, okay? Here, that's the same. FL language is done by a global system. The whole system is compiled. And everything that is not used can be dropped. That's possible. The frozen keyword allows you to say, okay, that is frozen, that will not be changed. Use it and optimize it. And as I said before, even if the semantic is to start a new execution context when a command is sent to an object, it can be optimized. Well, there are many challenges now. The coupling of the memory management and the garbage collector at the kernel system, improving security at an API level, optimization of activations, downsizing for tiny embedded component, that is dropping everything you don't need. Currently there is some issue on the separate keyword, but it's for the EFL community. And also, maybe the linker is not a good thing, then, well, just forget it. And so, prove that it's correct and useful, because safe and efficient. Well, back to the reality. Well, how many people I can answer? 1. Okay, how much money I can answer? 0. How many code reusable? Not much. How many supported platform? How many drivers? For the drivers, I think I have to check about RAMP OS and find some way of reusing what is done for by Kanti. Well, okay. So the planning. Well, I will first finish the compiler, maybe at the end of this year, and try to open the code as app. That's okay. Though I will try to start a request for common process for the kernel before true implementation. And well, that's all. Questions? Yeah. Please, please. Speak. Yeah.
So, your safety and security guarantees require everything to be implemented in Python, right?
Yeah.
And then you want to integrate C code drivers.
Yeah.
How do you make this together?
Well, there are many paths to do that. The first is just cross the finger, okay? The second is to use memory management unit to isolate the driver. And that's a long path, so maybe crossing the fingers is better, okay? Well, yes?
What is your target platform? Is it a PC hardware or is it an embedded hardware? I think in a small embedded system, this might be because you have a usually static problem in an embedded system. But on a PC, usually I want to start a new process and I cannot do that because I understand because I have to compile everything statically.
No, that's not true. Well, you're right, for embedded system it will fit. But for desktop system, then if you have some program that you create at the start, there is, it's Bertrand Meyer is calling that the Big Bang. Okay, you create the system, and the system say, okay, I will implement an interpreter, okay, a shell, and this shell is able to call the compiler, okay, so you got it. Not mandatory. No. You can also, but the question is interesting. Okay. Yes.
Have you compared your project with Singularity from Microsoft?
No. I should. Okay, great. Please repeat. Oh, That's a very interesting topic. But that's my pleasure. First, okay. Second, well, I'm experimented programmer, and I've not seen much language having such kind of property and design facility. That's obviously the best language ever made. That's true.
How do you compare this language to what you said your experience with C, C++? Why do you use this language in favor of C, C++, and why not? There isn't an area where one should avoid factors for the other?
Well, I expected that you understood that using mutexes, using shared memory, etc., is not good. But if you want to write your mutexes and implement any time that you have multiple resources to lock together it yourself, okay, we'll go. But for me, I want the simplicity of the design, the simplicity of the coding, the reusability, the safety, security, expressivity, etc. But I don't use C++. Okay, I know how to write C++. I wrote 15 years C++. I don't want. Okay. Yes, there are. Oh, it's a long story. Maybe 1 or 2 minutes. Only one. Okay. Currently, you can use FL Studio. That is that already implements separate, but you will only have 512 processor at most. Okay. There is LibertyFL, that is a fork of SmartFL. And there is also another compiler that is writing, these two one are written using FL, and the last one is written using C++. You will find it on SourceForge. But any of this compiler don't, they want to provide library, they want to provide things that you can use, but no, I want to make a kernel, okay? That's a major difference. Why? I want to reduce the library, let it open to any community and implement this way of thinking or this way of thinking. That's not my method, okay? Thank you.